Alright, Math 1, let's take a look at some graphing. So these first four we're dealing with are graphing in tables. Okay. Remember, the left side is the x, that's the horizontal, and the right side is the y, the output, that's the vertical. Okay. So we just turn these into points. So it'd be like 0, 6. So I stay at 0 and then I go up to 6. 1, 4 would be the next point. So I go to the right 1, up 4. Right there. Then 2, 2. To the right 2, up 2. 3, 4, or 0. So stay on the x-axis. And then 4, negative 2. So I go over 4, down 2. And then if I want, I can leave it like that or draw the line. Okay. So that's all you do with the table is each one of these basically turns into a point. A coordinate plane. So if you need to, just write them like that. But really you shouldn't need to. Okay. Now a few things to remember. We have some special numbers here. When it goes on the y-axis, we call that our Y-intercept. Usually when we're dealing with creating equations or story problems, we've also called it our starting point, our start number. Where that x is 0, or that input's 0, the output is our start number. Okay? And when it crosses the x-axis, it's called our x-intercept. Okay, those are some special terms to help us understand pieces of our graph. Then we should also be able to notice that on our table, as our table grows, okay, here we're subtracting 2, we can see that from every point to get to the next point, we're subtracting 2. And then on our input, our x, our n, that's going up by 1. We see that as we go to the right. So for each point, we go down 1 to the, or down 2 to the right 1, down 2 to the right 1. That's reflected in those tables. Okay? Alright, so let's graph number 2. So negative 4, negative 1 would be right here. Negative 3, 0 would be our x-intercept right there. Negative 2, 1. Negative 1, 2. And 0, 3 would be our y-intercept. And we've got that line right there. And that's all there is to it when we're graphing with a table. So negative 3, 6, we go back 3 and up 6. Negative 1, 3, back 1, up 3. 0, 0, going through the origin. So that one would both be an x and a y-intercept. 1, negative 3 right here, and 3, negative 6. And it would look something like that. And that one looks a little off to me, doesn't it? Okay, but that's alright, because we're just graphing using our table. This one actually looks kind of more curvy, doesn't it? So I'd probably just leave it like that. Number 4, negative 1, negative 5, down here. 0, negative 3, 1, negative 1, 2, 1, and 3, 3. Okay? So like I said, on these tables, you can draw the line or you can leave the dots. Okay? Now, the recursive form, because essentially we talked about this being our growth, okay, and this being our starting point, we can use that same idea. So if I wanted to, I could make a table here. Say my starting point is negative 4. My growth is I'm adding 1. So negative 3, negative 2, negative 1, 0. And so I'd be adding 1 here as well. Not because that's 1, but because I don't have any fraction or other thing like that. And then I could graph that. My starting point or y-intercept right there. Then 1, negative 3, 2, negative 2, 3, negative 1, and 4, 0, my x-intercept. And I could either draw the line or just leave it as the dots. And I could continue them even off the table if I wanted to. And knowing that the pattern goes like this, I could also fill in behind if I really wanted to. Okay? Now, do I have to make the graph, the table to do it? No. You can realize that this 6 is going to be my y-intercept, my starting point. My slope is I'm going down 3. So every time I move to the right one, I'm going to go down 3. So I move over to the right one, then down 3. And there's my x-intercept, to the right one, down 3, and so on. And again, I can leave it just dotted, or I can draw the line. Okay, so let's take a look at 2 more of these in recursive form. So starting at 1, adding 2, so I go to the right one, and then I'm going to go up 2. To the right one, and up 2. And there I go. For number 8, same idea. Start at -1. I'm going down 4, so I go down 4, and I go to the right one. Okay, and see I kind of ran out of space, so if I want to, I can take that same pattern of down and to the right one, kind of replicate it just going backwards. And once again, if I really wanted to, I can draw a line. But on these first 8, where it's tables or recursive, I don't have to. Okay. Now, when I get more to these explicit equations, I do need to graph and draw the line. Okay. But just like up here, where we had our starting numbers and our growth, on the explicit form, we have our starting number and our growth. Okay, so could I make a table out of that? Yeah. My starting number is -1, and I'm subtracting 4 each time. So -5, -9, -13, and so on. So 0, -1, then 1, -5, and then I could keep going to -9, be somewhere down here. And if I wanted to, I can draw off the graph. That's all right to do. Or like I said, we can go backwards as if we were going to -1, and we'd go up to +3. And I can draw my line if I so desire on this one. Okay, the other idea is just to use that starting number and realize it's on the y-intercept, and that +3 means every time I move to the right one, I'm moving up 3. Okay, or again, to the right one and up 3. Or I can do that same pattern backwards, down 3, and to the left one, and get my graph. Alright? Now, x and y-intercept. So we talked about what they were, and we can use them to graph. An x-intercept of -1, it's on the x-axis, the horizontal one, -1. Y-intercept of -4, it's on the middle y, -4. I've got 2 points. I can just draw a line using those. Okay, so 5, +5 right here, +5 up here, and there's my graph, or something like that. So x and y-intercepts are pretty easy to graph with. All right, now we're just taking this explicit form further to what we call our slope-intercept form. Slope being our growth, and y-intercept being our starting point. Okay. Now notice, instead of a sub n, we have y, which really doesn't make a difference. And normally we did the starting number and then the growth. So if we're looking at number 14, that's kind of what we've been used to seeing. But it doesn't matter, okay? It doesn't matter which the order you put them. What matters is that the growth is always with the variable and the starting number isn't, okay? So like on 13, if I wanted to, I could make a table again. Say my starting number is at +2, okay, and my growth. Now, this 1/2, okay, we did a thing in class using Desmos and realized that when we make a table, the top number is how we're growing on the output. And the bottom number, so this is our vertical growth, and our bottom number is the left side, okay? So we'd be adding 2 because it's positive each time. And so that's controlling our horizontal. So we'd have 0, 2, 2, 3, 4, 4, and 6, 5. Okay, and that would be our line. Okay, and that same idea, we can just use it looking at 14 and say, well, I start right here at -4. How am I growing? Well, I'm going up 5 because that's the top. It's positive, so I go up 5. So I'd start at this point and go up 1, 2, 3, 4, 5. And the bottom number here tells me how far to the right I go. So I'd go to the right, 1, 2, 3, and 4. And have this point right here. Up 5, 1, 2, 3, 4, 5. To the right, 1, 2, 3, 4. Okay? And then I could draw my line. Usually we like 2 to 3 dots to make our line. Okay? Alright, so let's keep doing these. So, same idea with 15. Now 15, notice it has a negative. Okay? Negative should always go with the top number. So it's like -2 over 3. So that vertical change is a -2, which means I'll be going down. And that 3 is positive, so I'll go to the right. So once again, I start at 4, -4 I should say. And I'm going to go down 2 and to the right 3. So right there. Now I could go down 2 and to the right 3 again. I make my line that way. Or using that same pattern, I could do the opposite. Going up 2 and to the left 3. That one works as well. Okay. Get my line and draw it. Now 16 looks a little different, right? Because you just have a negative x. Well, whenever you have a negative number, that coefficient, when you don't have the number there, that coefficient is always 1. Okay. Now, notice, with the fraction, the top number tells us if we go up or down, and the bottom if we go to the right. But we only have one number here. Okay. But remember, when you only have one number, you can always treat it as if it were a fraction by putting a 1 under it. Kind of going back to this same concept up here, when we knew the growth here, or here, we always moved to the right just 1. Okay, we always move to the right just 1. Same with this growth, always to the right just 1, just 1. That's because we were thinking of that as like -4 over 1, or 2 over 1, or -4 over 1, or +3 over 1. Okay, it was that same concept. So, it's like -1 over 1. So I start at 5, because that doesn't have the x. And I'm going to go down 1 to the right 1. Down 1 to the right 1. And I can just keep going as long as I want. But like I said, 2 to 3 dots, definitely enough to draw a line. Hopefully better than that one, because that was a horrible line. But you get the gist. So on 17 and 18, for our growth, think of it as like 2 over 1, or 4 over 1. And when we graph these, we call this growth our slope. And our slope we call rise over run. Okay, which means that vertical change over the horizontal change. Okay, so let's graph these. +3 to start, or my Y-intercept. 2, so I'm going to go up 2 every time I go to the right one. 3 points, that's enough to draw my graph. Okay, -5 to start us off. +4, so I'm going to go up to 4, so 1, 2, 3, 4 to the right 1. Up another 4 to the right 1, and there we go. There's my line. Alright, so hopefully you've tried some of these on your own. If not, try these last 6 on your own. Pause the video, and let's see if you can get them right, okay, on your own. So, here we go. So, +3, Y-intercept of +3, slope of -2. So I'm going to go down 2 and to the right 1 every time. Down 2 to the right 1. And if I really want to, I can just keep going. Or, thinking about that same pattern, down 2 to the right 1, I would have that same pattern, I'd go up into the left 1. Okay? And there's my line. Number 20, I'm back to having a fraction. Remember that negative goes with the top number, so +4. negative 3, so I'm going down 3 to the right 2. Down 3 to the right 2. So you can see here I went down 3 to the right 2, down 3 to the right 2. And there's my line. Okay, number 21. Now notice here, this time we don't have a number not with the x. Okay, in this case, we can think of it as plus 0. So I'd start at 0 here, and then my slope, negative 1, so I go down 1, and to the right 5, so right there. Now down 1 to the right 5 will put me clear out there, so usually what I like to do is then just take that opposite. So if I were to go down 1 and to the right 5, it'd have to be right there. Okay, and there's my line. Okay, 22. Got a positive 4 here. Positive 3 over 4, so I go up 3, which would put me about right there, and then to the right 4, so right about there. Or down 3, and to the left 4. And there's my line. So they're pretty quick because you can just look at them. But once again, if you're trying to make a table, I can remind you how to do that. So I'd say I start at negative 5. So 0, negative 5, 0, negative 5. The bottom moves here, so I go 0, 5. I'm counting by 5s because I'm adding 5 each time. 10, 15, and so on. And the top number tells me how I'm growing here. So it'd be negative 4, negative 3, negative 2. So 0, negative 5, I go to the right 5 and up 1. And I could keep doing that, but I kind of run out of space, so my line would look like that. So this last one, I'll do that again. That table, show you how to do it, if you like doing that. So I start at negative 3. This is negative 1, so on the rights, I'm minusing 1. So negative 4, negative 5, negative 6. And on the left, I'm adding 3. So 3, 6, 9. So I go 0, negative 3. Then I would normally go down 1 and to the right 3, which would take me at 3, negative 4, down 1 and to the right. And 6, negative 5. And so on. Alright guys, so there we go with the graphing. Hopefully you made those connections, and this practice helped you with that.